All right, if you've ever worked with data in Python, you know the feeling. You start with a simple file, but pretty soon, it's chaos. Well, today we're going to fix that. We're going to level up your data skills, moving you from that all-too-familiar mess into the clean, powerful world of databases. And we're going to do it all right from inside Python.
I mean, take a look at this. This probably looks incredibly familiar, right? It's your classic flat file, a CSV. You've got authors, their books, their publishers, everything's in one place. And look, it's simple, it's easy for a human to read, and honestly, it's where most of our projects start out. I'd be willing to bet you've got a file just like this sitting on your hard drive right now.
So let's be real for a second. Does this hit a little too close to home? Just notice all that repetition. Stephen King's name listed over and over and over. Same for the publisher, Random House. If you're sitting there nodding along, you are definitely not alone. But the good news is there is a much better way.
And that's really the heart of the issue, isn't it? What feels simple at the start actually creates a ton of hidden problems down the line. I mean, just imagine the author changes their name. You'd have to go hunt down every single entry and edit it, just praying you don't miss one, or worse, make a typo. That's the exact kind of headache we're going to fix today. So let's just call this what it is. It's the flat file trap. It looks easy, it feels convenient, but it's a trap that ends up costing you big time as your project grows.
Now, to be fair, let's break it down. There are some advantages, right? They're simple to create. Anyone can open them and see what's going on. And they're super portable. But, oh man, the disadvantages. They get out of hand fast. All that repeated data, that redundancy, it makes updating a nightmare. And trying to manage real relationships like which authors work with which publishers, it becomes almost impossible.
You know, one of our sources for this, RealPython, they put it perfectly. They said, the advantages of working with flat files start to diminish as the data becomes larger. And that's it right there. The very thing that made it feel easy at the start becomes your single biggest roadblock later on.
So how do we get out of the trap? Well, we start with our first big upgrade, SQLite. This thing is amazing. It gives you the full power of a structured database, but it lives inside a single file on your computer. No server, no complicated setup. It is the perfect next step.
And the key idea we're going to use is called database normalization. Now, don't let that fancy term scare you. It's actually a really simple idea. It's just the process of organizing your database to get rid of all that repetition and, in the process, make your data way more reliable.
And you can see how it works right here. It's actually pretty intuitive. You just look at that one big, messy table, and you pull out the distinct things in your data. For us, that's authors, books, and publishers. Then you give each one its own clean, separate table. And just like that, poof, Stephen King only exists in one single place. Random House only exists in one place. It's clean, it's efficient, and it is so much easier to manage. Okay, so everything's in its own tidy little box now. That's great. But how do they talk to each other? How does our database know which author wrote which book? Well, this is where we get to do something really cool. We're going to build some smart relationships.
We do this with two special kinds of keys. First up is the primary key. The easiest way to think about this is like a doctor's unique ID number. There's only one for that specific doctor. Then you have a foreign key. This is like putting that doctor's ID number onto a patient's chart. The chart doesn't have all the doctor's info. It just has a little pointer, a direct link to the right doctor.
And here's what that actually looks like. See? The author table gives Stephen King his own unique primary key. Let's say it's ID number 1. Then, over in the book table, instead of typing out his name again for The Shining, we just put the number 1 in the author ID column. That little number is the foreign key. It's the thread that connects that book directly to its author with zero repetition. So when you need to see it all together, how do you do it? It's surprisingly easy. You use one simple command, a SQL join. You basically just tell the database, hey, follow that author ID link for me, and it stitches the data from the two tables back together instantly. It's efficient and it's incredibly powerful. But we can take this even one step further. We can make all of this database work feel truly, well, Pythonic. And that's where a tool like SQL Alchemy comes into play.
It's what's called an object relational mapper, or an ORM, and it acts as the perfect bridge between our Python code and our nice, structured database. SQL Alchemy is designed to solve a classic problem that has a really fancy name: the object relational impedance mismatch. All that means is that it can feel really clunky and awkward to just shove raw SQL queries, which are just strings, inside your nice, clean, object-oriented Python code. It's like two different languages trying to talk to each other. SQL Alchemy is the translator.
And you can see the difference it's night and day. On the left, you've got this raw SQL query living as a string in your Python. On the right, though, that's just pure Python. We're not writing SQL anymore. We're calling methods on Python objects. It is so much cleaner, it's safer, and it lets you stay in that Python mindset instead of having to switch back and forth. Okay, so we've got it. Our data is structured, our code is Pythonic. To wrap things up, let's go over a few pro tips to really supercharge your performance and make sure you're getting the most out of this new setup. Let's start with a hard number. Check this out. One analysis found that by using a batch insert method to add 1 million records, it was over 31% faster than just doing it one by one. Why? Because you're cutting down on all the back and forth communication with the database. The takeaway here is crystal clear. If you're doing bulk inserts, batching is a massive, massive win.
All right, here are some rapid-fire tips straight from the sources. For those fast batch inserts, you want to use the execute many method. Always, always use a with statement to manage your database connections. It handles all the cleanup for you automatically. If you get into multi-threading, make sure each thread gets its own separate connection to the database. And a really cool one, for super fast temporary databases for testing, just use the file name, quotes, memory, quotes. It will build the whole thing in your computer's RAM. It's blazing fast.
And there you have it. We've taken a journey from a tangled, messy flat file all the way to a structured, optimized, and truly Pythonic database. You've unlocked a whole new level of power and integrity for your projects. So I guess there's only one question left to ask. Now that your data has structure, what will you build?